Hey math kids, today we're going to talk about conditional probability. Let's see. Okay, and it's all based around this formula, and specifically this line means given. So this is probability of A happening if we know that B has already been given, or the probability of A given B. So that's the important part. So when we're doing these two-story problems, you're going to see we're going to be given too much information, but we have to determine which one has already happened, and we will use that piece. So let's just jump right in. It says Frank Zieg surveys their gym class and determines that 20% of their classmates have Obama robots, or Obama bots for short. Okay, so we're going to say Obama, and what was that? 20%. Okay, and then 40% have pig robots, or Pigobots for short. That's 40%. Okay. They also determine that 10% have both. Okay. If they asked a random student who has a Pigobot if they have an Obama bot, what is the probability that they would say yes? All right, so we're assuming everybody's going to tell the truth, so we don't need to get into that discussion. But right here, it says we're only going to ask people who we know have Pigobots, and so that is the thing that we know has happened, and so that's the one we're going to use for P of B. So in this case, we're using 40% as our P of B. We actually don't care about this. And then the top of this is our both. And so we'll be using this one as well. So we just take the both, divide it by the P of B. So we're going to say 0.1 if I change that into a decimal, and then 0.4. And if I divide those with a calculator, I'm going to get 0.25, or 25%. So if we talk to people who we know have pig bots, there's a 25% chance that they also have a Obama bot. Okay? And let's move on to the next one. I guess I'll just erase this real quick. Now, as we're reading this one, it says Tim and Eric asked a randomly selected group of people if Dr. Steve Brule's rules were A, ridiculous, B, informative, or C, both. The results were as follows. So we have ridiculous is 50%. We have informative is 35%. And we have both, which is 25%. So what we need to do is read the rest of this to determine which one we're using. So if they randomly selected one of the people who believes Brule's rules to be ridiculous, what is the probability that they also believe Brule's rules to be informative? Okay, so we're narrowing our total down to people who think that it's ridiculous. So we don't actually care about this anymore, and then we'll also use the both. So remember, we take the both and we divide it by the P of B. In this case, this is our P of B. And so we're going to say 0.25 divided by 0.50, and that's just going to be 1/2, or 0.5, which is 50%. So if we know somebody thinks that Brule's rules are ridiculous, and we ask them, do you think they're informative? about half of them will say, yes, I think they're also informative. If you need additional help, please come to Math Lab. Until then, calculator.